Alright, so today we're going to continue our work with circles. So it says, find the area of the following semicircle, use pi, which equals 3.14. Okay, so notice here, I know that you probably already noticed that we do not have a full circle, we actually have a semicircle, which means half of a circle. But we're going to start by just solving for the area of this as if we had the whole circle itself. Okay. So it's a good habit to get into before you do anything. Always just define what is the diameter, what is the radius. So it always will give you one or the other, otherwise you wouldn't be able to solve. In this case, it gives you that whole line that goes right across the middle of your circle. That is your diameter. So diameter equals 14 centimeters. So then that would mean that our radius is half of that, because radius is always exactly half of the diameter, and that would be 7 centimeters. Okay? And then from there, we just want to go ahead and decide, well, what equation do I use, or what formula do I use to solve for the area of a circle, because we're solving for area. Well, we're going to be giving these to you throughout the unit, but the area of a circle is always right here. So it's 3.14, which is pi, so pi times radius squared. Okay. Now for some of us it's easier to think about, well, what is radius squared? What does that mean? It just means radius times radius. So if you want to think about the formula as 3.14 times radius, go ahead. It means the same thing. Okay, so we're just going to plug in what we know here to find the area of this semicircle. So we're going to go 3.14, just like the formula says, times radius, which we now know is 7, times 7. So all I did there was plug in what I knew for radius into my formula, and now we're just going to carry this out. When you do 3.14 times 7 times 7, you get 153.86, and it's centimeters squared. Okay, which means that every square centimeter is, there's 153.86 square centimeters in our semicircle. Okay, so you're almost done here, but note that you didn't have a full circle, so this would be the area if that circle just continued, but you don't have a full circle, you only have semicircle, which is half of the circle. So we want to take half of our answer. So how do you take half of 153.86? Well, there's a couple different ways you can do it. I like to divide by 2, so I'm going to go ahead and do 153.86 and just divide it by 2 so that you get that half circle. And when you do that, you get 76.93. And then if you wanted to, we'll go ahead and round that, centimeters squared, or how about 77 centimeters squared. You could round that up if you wanted to. Either answer would be fine. Now, if you like to have more than one way to do it, you could also go ahead and say, well, I need half of my 153.86, and the other way of getting half is to multiply by a half. So 153.86 times 1/2, and when you throw that in your calculator, you'll get 76.93 centimeters squared. So it does not matter how you do it. Either one of those ways is fine. I would just pick one and focus on it. Most of us are probably going to do this. So if you want half of something, just divide by 2. Okay. Okay, so here's the second problem in your notes. This will be on this is the second slide on your note page. So here again it says, if we read the problem carefully, what is the area of the quarter circle? We should do some annotating here. So what is the area, okay, of the quarter circle? Okay, so we're trying to find the area of a quarter circle. So again, first, just like you did last problem, we need to just pretend that this circle, let's use a different color, just kind of keeps going, and we got a full one. Let's just pretend that, and then we'll deal with the fact that it's a quarter circle later. So if we look to our formula, how do you find the area of a circle? It's always pi, which is 3.14 times radius squared. So let's go ahead and do that. And remember, radius squared is radius times radius. So we want to go ahead and radius equals 6 centimeters. That means the diameter, although you won't need it in this problem, would be 12 centimeters. It's a good habit, again, to just do that in each problem. Okay, so now let's go ahead and refer to our equation and just plug and chug. So we have 3.14 times radius, which is 6, times radius again, which is 6. Okay, and when you go ahead and carry that out, you get 113.04, and this is centimeters again, squared, centimeters squared. Alright, so the whole area of the whole circle is 113.04 centimeters squared. However, it asks for a quarter of it. So now this time we want to take a quarter. Alright, think about quarter, think about how many quarters are in a dollar. There's 4 quarters in a dollar, so we want to take 1/4 of this area, so we get a quarter of it or a fourth of it. To do that, you can do it 2 different ways. I like to think about, well, if I want to take a quarter or something or a fourth or something, you divide by 4. So you want to go ahead and divide this by 4, and I might write that out. So 113.04 centimeters squared divided by 4. Either way you show it is fine, and that equals, when you do that, 28.26 centimeters squared. Alright, so that goes down there. And that is your answer. Now, here's another way you can do it. You can go 113.04, which is, again, the area you calculate for the whole semicircle, and you could multiply it by, instead of half this time, by 1/4, and you're going to go ahead and get the same answer, 28.26 centimeters squared. So either way is fine. You get a final answer of 28.26 centimeters squared. Alright, so now we're just going to apply some things that we've learned in the past in this unit and in prior years to solve a little bit more complex problem, although you have all the skills that it takes. So it says, Marjorie is designing a new set of placements for her dining room table. She sketched a drawing of the placement on the graph paper. So here's our graph paper. The diagram represents the area of the placement consisting of a rectangle and 2 semicircles at either end. Each square in the grid measures 4 inches. Okay, find the area in the entire placemat. Explain your thinking regarding the whole solution to this problem. So let's go back through and let's underline what's really important. So it says the diagram represents the area of the placement consisting of a rectangle and 2 semicircles. Do you know how to find the area of a rectangle? Yes. Do you know how to find the area of semicircles? Yes, we've done that. Okay. At either end, it says each grid measure is 4 inches. All right. In length. All right. So find the area of the entire placement. Explain your thinking. Well, first of all, this part right here, grid measure 4 inches in length, that means that each one of these is 4 inches. 4 inches, 4 inches, 4 inches. So let's go ahead and dissect this problem into 2 different problems. So first we have the square. So we want to find the area of the square first. And the square here is nice visually in red. So each one of these is 4 inches. So this is 4, 4, and 4. And then that's the length. And then the width would be another 4 and 4. Okay. So what does that turn out to be? Well, 4, 4, 4, that's 12. So it's a 12. The square equals, it's a 12 by, and then we have 4 and 4, which is 8. Remember, why am I doing 12 by 8? Area of a square, or rectangle I really should say, is length times width. Okay, so 12 times 8 will give me the area of the square in this problem. So 12 times 8 is, I believe, 72, but I'll check myself. 96. Good thing I checked it. 96 inches squared. So now I know a lot of it. I know this whole part is 96. Okay? But now I'm going to go back. And I know that that's not the whole object because I also have to figure out my 2 semicircles. So I have this semicircle and this semicircle. think about what would happen if you put this semicircle with this semicircle. You would have a full circle. So just think about one of these semicircles as being a full circle and what we know about circles, and then just go from there. So your two semicircles, I'll draw that down here. So let's go ahead and find one of them. If we find one of them, the other one will be the same. So what do we need to know about my semicircle? Well, if we look at our formula, we want to know how the area of a circle is 3.14 times radius, so we want to know the radius. Well, what do we know? We know that if we look at our circle, we do have this dimension that goes all the way across, which is our diameter. So of our semicircle, the diameter equals 2 4s, because we have 4 plus 4 to get the whole way across, which is 8. And if the diameter is 8, the radius would equal 4. So now we know that radius of our semicircle. So we have enough to plug and chug into our equation. So we want to take 3.14 times, it says radius, so times 4 times 4. And when you go ahead and do that, you get 50.24. So now again, this is for the whole circle, so that would be if this was a full circle. So there's two ways you could do it. Keep in mind here that you actually have two semicircles. So instead of taking half of this and then redoing this same exact calculation and taking half of it again, you could just think, well, together I do have a full circle. So the area of my two circles together is exactly 50.24. Okay, so now that we know that this region and this region is 50.24, we can go ahead and add up, well, what was the total area? We have 96 inches squared for your rectangle plus 50.24 inches squared for the circle, the two semicircles. So when you go ahead and add that math up, you get 146.24. Okay, now that was a kind of a lot going on in that problem. So as you're doing this, if this one's not making sense, it would be a good idea to advocate for some assistance, and we could do this one together instead of trying to struggle through in the video. Alright, so now there's another part to this problem. So we have, it says Marjor decides that she wants to sew a contrasting band of material around the edge of the placement. So she wants to sew all the way around this. How much band material will Marjor need? Well, what we're really talking about here is finding the perimeter of this area. So to do that, first, why don't we maybe start with our circle? So we'll continue to work in blue. How do you find circumference of a circle? Alright, on this one it says example 3, the circumference of a circle is 28.26 centimeters. And it wants us now to solve for the diameter. So we still want to go back to our formula for a circumference, and here we have it. And remember, we're going to supply these to you throughout the unit, but circumference of a circle is diameter times 3.14. So the only thing that's different about this is we know the area, or the circumference I should say, of a circle instead of knowing like the diameter or the radius and solving for the circumference. So let's just again refer to our equation and fill in what we know. So circumference equals diameter times 3.14. Well, I know the circumference already, so that's 28.26 centimeters. Equals, and you don't really need that in your equation, 28.26 equals the diameter, it does not give that to us, times 3.14. And if you think back to just last unit, this just turns into an algebra problem. So think here, start on the side where you have your unknown, which is your diameter, and undo what's by it, which is this multiplied by 3.14. So to undo multiplied by 3.14, you divide. So divide by 3.14, divide by 3.14, and you end up with the diameter by itself, which is what you wanted, which equals, let's see here, exactly, believe it or not, 9. So your diameter is 9. So what is the diameter? D equals 9, and it's centimeters. Okay. So then what is the radius? Well, how do we find the radius if we know the diameter? You take that diameter and cut it in half, divided by 2. And that would be 4.5 centimeters. Okay. So now it asks for the area. Well, let's think of the formula for area of a circle. Okay. It's always area equals, for a circle, 3.14 times radius times radius. Some of you think of it as 3.14 times radius squared. These two things, radius times radius and radius squared, same thing. So either way works, either one of these two. So let's plug in what we know. We know that the area must equal 3.14 times radius. Well, radius times radius is, the radius is 4.5, so 4.5 times 4.5. And when you go ahead and do that, you get 63.585. And now this time it will be centimeters squared because it's the area. Okay. So we could round that if you wanted to 63.6 centimeters squared. But either way, your final answer is one of these two.